Good evening everyone. Today I am going to discuss closed loop control of buck converter using embedded C coding, not MATLAB. But in the previous session I have already discussed using MATLAB. Now the same MATLAB concept with the help of DSP embedded C coding I have developed buck converter closed loop control. I will explain one by one about the buck converter operation with the C coding. So now you can see this is the embedded C coding, so which I have developed by using simple C coding language. So now by using closed loop control, before I explain, previously this is the MATLAB. So the same concept I have taken 15 volts, 10 volts and 7.8 volts. So the same this concept how I developed by using model based development. Instead of model based development, now today I am going for the coding. So but the concept remains same, only for 15 volts you have to get 3300 and 10 volts you have to get 2200 and 7.8 1500 ADC reference. So now in the coding, the where we have used the PI controller, I will show here. So this is the PI controller, we have used the concept of the PI controller here. So first we are calculating error, right, V reference minus V out, and next integral operations we have taken. Next finally duty cycle I have taken over here. So and if you want the PI values, I will show the PI values, what are the PI values we have used. So this is the 0.4 and this is the 0.001 I have used for buck converter. So the same I have used this concept over here, and I have limited the maximum duty cycle to 0.85. And next I have given a provision like for the user. For example, user may enter 15 volts, user may enter 12 volts, user may enter 10 volts. So for that I am using here one just small circuit. I have developed one small circuit with my student help. So and that is by pushing the buttons we can change the reference voltage. So based on the reference voltage your output voltage is going to be controlled. So now this is the logic for this push buttons, right, to increase the reference value, and this is another logic to decrease the reference value. That means the user may enter from 0 to 15, the user may also enter from 15 to 0. So like that, one is for increment case, another for decrement case. I have used this one. Now I will explain the hardware by running this program. Now I will run the program. Already the program is ready. Now I will run the program. Now what happens is, whatever the ADC channel, here ADC channel I have taken over here, this ADC channel voltage, that means feedback voltage of your rheostat, that rheostat now rheostat voltage by using this ADC voltage I will show in the graph here. The same I have developed in the MATLAB. So that means for ADC 15 volts means that is equivalent to 3300, that means 3300. So that I will show here, and I will parallelly I will show the output voltages and all the things. So now I am running this program. Now you can see initially I have set some PWM signal and already have applied 20 volts, right. So now we will go to the 15 volts setup, right, by increasing this switch buttons. So this is for increasing switch button and this is for decreasing switch button. So now once I increasing this switch button, I will show the V reference how it is increasing. So the V reference here already I have taken, so that is nothing but ADC result. So this ADC result I have added in the graph. So I will show, and so this is the graph. So now I will increase the push button. So now I will increase the push button. Now you can observe here duty cycling is increasing as well as your voltage is also increasing. So now you can see the voltage, it's increasing randomly. So now I will set to 15 volts. So this is the 15 volts I have developed. Now you can see the 15 volts. So that is nothing but this is 3300. So it is equivalent to this value. So my reference voltage I have set to 3300 volts, right. Now if I change I will decrease, because I have given a provision to the user. User can enter from 0 to 15 volts and he can also decrease from 15 to 0 volts. Now I will decrease it, whether it is decreasing or not. Yeah, it is decreasing now. So now you can see, by decreasing that one, obviously the duty cycle is also changing. So now you can observe the duty cycle and the curve parallelly. Now the duty cycle is changing, decreasing like this. So the output of your converter voltage is also going to be decreases. This is the converter. The converter output voltage is decreases now. So just now I have shown by using the curves and the CRO. Now I will show with the help of this multimeters. This is a load voltage and this is a load current. So previously I have explained with the help of graph. Now with the help of converter also I will show. So first initially I have increased up to 78 duty cycle, 78%. Meaning of this one is I have given a reference voltage of 15 volts, which I already shown here. So this is the curve. So 3300 means it's a 15 volts. That 15 volts now I am showing here. It's almost equivalent to 14.7. So this is the 15 volts. Now I will decrease the voltage. Once I decrease the reference voltage, obviously that ADC channel voltage should reduce, as well as the output voltage should also reduce. Now I will show this one. So by reducing this one, you can see. So now the duty cycle is reduces, the output voltage also reduces. Now again still I will reduce the reference voltage. See the reference voltage. So the reference voltage I am reducing. Once the reference voltage is reduces, duty cycle is reduces, again the output voltage also reduces. So in this way I will completely reduce the duty cycle reference voltage. You can see the reference voltage completely reduces, and duty cycle is reduces, and the output voltage also reduces. Now again I will increase it. So I will increase it. Now you can see again it is increasing. The reference voltage there, reference voltage is increasing. Obviously the duty cycle will set automatically. This is the closed loop control of buck converter. So now the main important thing is closed loop control. Whenever the load current changes, the duty cycle should adjust automatically to maintain our voltage as constant. So our voltage, my voltage requirement I have set to 3300 here. So that is nothing but 15 volts, right? So now I will change the load current. So whenever I change the load current, you can see the current is changing here, but my voltage is constant, and duty cycle will adjust it automatically. So but my voltage 3300 remains constant. Now I have reached to 1.25 amperes. So still I will go for one more 1.5 amperes. So but still my duty cycle is adjusted automatically to maintain the voltage as constant. So this is what has happened in the buck converter. By using embedded coding I have done this one. You can see still the voltage is maintained as constant. Now just for I will reduce the current. Again I will showing that see duty cycle is adjusting automatically as reducing to maintain the voltage as constant. Okay. So now what I want to say, tell you is, last time through WhatsApp some of the people has commented like MBD can do anyone, so do the coding. So today I have done the coding. I have taken it as a positive way and I have done this one, and today I have shown the experimental result also. So a lot of people will say that the coding is, embedded coding is very difficult. It's not difficult. You can see I have used a simple if, else and while loops and counter concepts only. You can see here. So simple if, else, while loop concepts and function concepts. See some functions I have used and for loops I have used. The only thing is you should be able to study the textbooks. So what are the textbook I will show? This is the textbook. Texas Instruments you can download from the website, and directly they will give how to configure the ADC channels, right, in the textbook. That configurations you can do and do the coding. And if you want, you can take the ChatGPT help also, but it is almost giving wrong answers only. But if you need it, you can do, but mainly thing is the textbook knowledge is most important. If you study the textbook concepts and automatically you do the closed loop control, the same concepts I have explained here. So it is very simple coding kind of thing. But when you go to product based companies like ZF, Bosch, right? So Value, this kind of companies, they are using MATLAB instead of using embedded C coding. So MATLAB, because MATLAB is a matrix laboratory which can convert the blocks into the mathematical form. So its validation is more in MATLAB. So that's why it is always I am always recommended to use the MATLAB instead of using the coding. But some companies are also using the coding. So the only thing is just study the textbook perfectly and see it, and do this kind of small setup, and obviously you will able to get the required output voltage and current. So and do for the boost converters, buck converters, buck boost converters, like that. So this is the explanation of your closed loop control of buck converter using embedded C coding. Thank you.